We're going to dig a snow pit here to analyze the snow. Now there's a procedure we follow to keep all snow pits with a standard makeup, so to speak. And one of the first things you got to do is control for your sunlight. Once you open up the snow, it's going to start to warm up. So you want your pit wall that you're working in to be perpendicular to the sun. The sun's right up here, and I'm going to make a pit wall that will be perpendicular to that. So we draw a no-pass line, and that line is a straight line coming across here, perpendicular to the sun itself, coming straight across like that. The right-hand corner of the pit is always your equipment end of the pit, and so nobody ever walks over there. We're going to put a right-hand end right about here. And then what we'll do is do a quick dig down in front to move our snow before we touch up the back wall to start working on. So I got a couple of folks here who are going to help me. You folks want to come on over and do a little bit of digging? We'll take turns here. We got Carly and Alex to help dig. Take turns. This snow is spring snow. It's got a little weight to it. Got to work some. Of course, we got a big rock, don't we? Now, careful, don't pry up because it'll rip, cut down first, all the way back. I'm going to clean up this edge now and make a working research edge and an edge where we can put our equipment. And we want those to be clean. Now in today's pit, we're examining the snowpack formed on top the ice of a river. We could be digging a snow pit though down on to ground also. Now usually when you go to dig a snow pit, the weather is blowing 90 miles an hour and snowing 6 inches an hour, and so you got to be very careful with your equipment. So what we do is we make a little platform right here where all the equipment's going to be placed, and whenever you lay something down, it's laid down in the platform. So we're ready to start working now on the snow pit itself and getting some data. Let's see, why don't you guys bring the snow kit in. Okay, so we got a kit, a couple of us are going to be working here. This is our snow kit, goes up on the shelf, and we pull out the equipment we need. Being very careful, one of the first things we'll do is get out our thermometer, and the thermometer is a delicate instrument in terms of the cold. So one of the people will be a thermometer person, and it's their job to keep the thermometer warm because the cold saps the batteries out very quickly. And let's give that to Alex. So you want to put that inside your shirt. First thing we're going to do is look for layering in our pits. And we have some heavy-duty cards here. These cards we're going to use to work our way through the snow and find out how many layers there are of snow in the pit. And we'll mark each layer as we do it. So here we've got a set of markers, and we've got our sample. We're going to define the layers in the snow here. First thing we do is place a ruler to draw a line to work alongside of. And so I've got a ruler, and it is reading in metric because the equations we'll be using later to calculate information about the pit are in metric. Then we take a hard card of some sort, could be a credit card, but we've got special ones in the kit. And we work our way down until we hit a difference, and right here I have got a hard spot. So I'm going to put a marker there, and then I'm going to work my way down past it, and right there it changes and gets very soft. So in this pit we've got 1, 2, 3 layers. The next thing we need to do is get temperatures, and to get temperatures we're going to have to make sure we work in the shade. So we take our shovel, and the shovel is placed back here to create shade over the snow for our air temperature. Now the person with the thermometer, come on in over here. With the thermometer, the temperature is taken right here at the tip of the thermometer. And if you hold this metal, it's going to feel your warm hands and give you a false temperature. So you have to hold on the plastic. First temperature we take will be at a 45-degree angle. That will be the interface between the snowpack and the ground, or in this case the interface of the snowpack and the ice. Then each subsequent temperature will go perpendicular into the middle of the pack. There you go. Now what's going to happen, since we're doing highly precise digital readings here, is that temperature value is going to bounce up and down before it settles down, and you got to watch it till you're sure it's settled at the lowest point it's going to settle. What sort of temperatures we got there, Alex?
Yeah, negative 1.1 C.
Right now it's negative 1.1 degrees centigrade. One person writes this information down off to the side so that we can keep track of it. So we have a recorder over there writing down all the values we give them. And it looks like we're stabilizing at about 1.4. The middle of the layer's there, so straight in the middle. Yeah. And then when you get a temperature, you tell us when you're ready. Now while we're working on temperatures, what we're going to start doing is measuring the density of the snow. And what we'll do to measure the density of the snow is we use a pie cutter. And the pie cutter cuts out a block of snow exactly 200 cubic centimeters. We push it into snow, we cut off the top, and we'll have a block of snow in here that we know the volume of, and we will weigh it, and then we can calculate the density. Now what we do is place this in the middle of the layer and shove it into the snow. And Carly's going to work on using the pie cutter here. Go ahead here and work your way down. Now, can you get down right in there? Yeah. And reach forward. Go ahead and work on the far side over there. Yep. Yep. Do it in the middle of the layer. The middle of the pie cutter goes in the middle of the layer, and you push it in until it's completely full. Then you bring the top down to cut the block of snow. How are we doing on temperature there, Alex?
Still dropping.
Still dropping, okay.
Down to -2 C.
Right now the temperature is still dropping, but it's down to -2 degrees centigrade. Okay, what we need to do right now is get the density of the snow, and we're going to do that by taking a known volume, and that volume will weigh the weight of. Okay, before you take the lid off, put it in your sack so you don't lose anything. We're going to dump the snow into the sack. Let me hold it a minute and you go to work. Actually, okay, no, not hands, with your cutter, the tip of the cutter. Okay, we're going to get all the snow into this sack. Bounce it a little. Okay, now with the cutter we keep scraping until we've got it all out of there. Yeah, that's it. You got to turn at an angle. Good, good. We want to get every bit of snow because that's going to influence our density reading. How are we doing on temperature, Alex? Okay, layer number 1 has a temperature of -2.0 C. Take this one to scrape with there. Okay, so we've got our snow in a little plastic bag. The little plastic bag is going to be like a weather vane in the wind, so we roll it up tight, and what we will do is get shoulder to shoulder here and weigh it with a scale. Now the reason we're shoulder to shoulder is so that Carly can look at it and make sure it's not hanging up this way, and I can look at it and make sure it's not hanging up that way. But the scale we tried with initially, it bottomed out, so we got to get a bigger scale. Now we've got a scale that can weigh heavier weights, and Carly and I get side by side. Is it vertical?
Looks like it.
And what reading do you get there?
57.
57. I think that's what I'm getting too. So we got 57 grams of snow and bag, but the bag itself weighs 1 gram. So what we're going to do is dump that out, but our data of 57 grams of snow and bag, we subtract 1 for the bag, so we've got 56 grams of snow in 200 cubic centimeters of volume. And if you divide 56 by 200, you will get 0.28, and that is the density then of the snow of 28% water, or 0.28 grams per cubic centimeter. Now we got to get a density reading for the middle layer. Since we had 3 layers, this will be layer 2 up. While Carly's cutting out another density, Alex is going to move up and get the temperature in the middle of the second layer.
54 to 56.
So 55. So we've got 55 for bag and snow. Subtract 1 for the bag, makes this 54. 54 divided by 200 cubic centimeters would be 0.27 grams per cubic centimeter, or 27% water. We got 54 grams for the bag and the snow. Subtract 1 gram for the bag, makes it 53. 53 grams of snow by 200 cubic centimeters would be 26.5 for percentage, 26.5%, or 0.265 grams per cubic centimeter. So we've got density layers readings in all our layers now. How are we doing on temperature? The middle layer is minus 2.7 degrees centigrade. Let's get the top layer. This is probably going to start to warm up because of the effect of the warm day. The temperature on layer 3 is minus 0.6. Now we need the next temperature has to be the snow surface interface. So you're going to hold the thermometer just with the tip just under the snow, in the shadow of the shovel. The temperature at the ground snow interface appears to be a positive 0.2 degrees centigrade. Now we need an air temperature in the shadow and close to the shovel. We're trying to get reduce the effect of the wind and also not get any solar radiation hitting our thermometer. Now with that wind blowing today, that temperature is going to bounce around a little bit up and down. It's finally stabilizing at 6.8 degrees centigrade. We're going to try to determine the size of the snow crystals. I've got a snow card here with grids of 1 millimeter, 2 millimeter, and 3 millimeters. What I'm going to do is clean out the area where we were working, clean off my card, and then work it in at the bottom and knock grains of snow on top of that and break them up a little bit and study them with the magnifying glass to try to see what they look like. And these particular grains have facets on them and are 3 millimeters in size for the biggest ones, and there's some pretty good cup-shaped facet crystals there. This would then, according to our snow classification system, be Roman numeral 3 for temperature gradient or constructive metamorphism, and they would be classified B because they formed starting down there at the ground, and they're mature, so they would be 3B3. So we get the snow classification for each of our 3 layers and record it also. This takes care of our basic information from the snow pit. We're going to try to get a little bit more information in a minute in reference to avalanche danger and hardness of the snow. On hardness, we take and start testing by pushing a fist in. If it easily goes in, we would call that fist hard. If it takes some pressure, then we switch to 4 fingers, to 1 finger, to pen, to a knife. So I'm going to start here with my fist, and I'm pushing, and it's probably I would call that 4-finger hard. Second layer up, I push in there at the fist. Fist doesn't quite want to go. 4 fingers goes in. 1 finger. I'm going to call that 1-finger hard. Top layer, fist, doesn't want to go. 4 fingers doesn't want to go. Finger barely goes in. And if I take a pen to push with, or a pencil, so that's pencil hard. Okay, we're going to run a very little simple avalanche test to get an idea how stable the snow is. In order to do that, we're going to create a pedestal. We'll call this a pedestal test. First, put a shovel in and cut an edge on one side and then an edge on the other side, so it's about the width of the shovel. And then we're going to remove the snow next to our pedestal on both sides. We've now isolated a pedestal. We'll put the shovel in next to the pedestal facing back and watch it. As we drop it in, as the weight of the shovel goes down, sometimes that'll create a break. This time it didn't. The weight didn't break it. What we want to do is watch the pit and try to decide if it breaks, where does it break? At which line? And it looks like it's broke at that bottom of the first layer. So that's not stable. And then it goes clear down into layer 3. So the boundary between layer 1 and 2 is a fracture zone, and then the middle of layer 3 was soft enough that it fractured there.